In fact, speaking of cool things, we're now going to turn it over to the team at WP Engine because they built some cool stuff. They were actually able to build an observability platform using InfluxDB. So without further ado, I'm going to pass it over to Tanny and Nadeem. Are you guys ready?
Yes. Hello. Oh, cool. Hi, everyone. Thank you so much for joining us in our session on transforming monitoring into an observability platform with InfluxDB. So WP Engine is the leader in WordPress. We power more than the top 10 million sites than anyone else in WordPress. This is about 8% of the web passing through a site that's powered by us every day. So this translates to serving 5.2 billion web requests per day. To deliver on this service to our customers, Built for Growth is one of the core values that drives observability. The customer-inspired values resonate with my product ethos and are a key reason why I joined WP Engine. So let's talk about monitoring system. How many of you have experienced outages when you were completely blind? I never wish this for anyone, but in August of 2019, WPE had an almost 24-hour outage where we were blind because our monitoring system had one single point of failure, and not to mention how it further degraded other dependent services. Luckily, there wasn't any big customer impact, but the inability to provide our customers with an effortless experience they can trust made it very clear to us that we had hit the limits of our architecture. So to put this in perspective, we used to be proud that we were the largest known Zabbix deployment with more than 15,000 hosts on one Zabbix server. This is about more than 50% of a comparable Zabbix case study that they have on their site. So Zabbix was the right solution for us when WPE first started. But after repeated attempts at extending it, after repeated attempts to extend it and more frequent downtimes, it was clear we were not building for growth anymore. So I was brought into WP Engine to transform our monitoring system and address those top business risks. Oops. Am I? Oops. There we go. All right, so I am Teddy Ng, the product manager for observability, and my engineering partner, principal software engineer Nadeem Syed, are here today. Together, we're going to share how we transformed monitoring into an observability platform. The process wasn't easy. We did some things right. We learned a difficult way. So hopefully these tidbits will help you in your observability journey. So our plan today, I'll recap some of our key pain points and where we're at, and Nadeem will go through our architecture and learnings. In early 2020, our monitoring solution was at its limit. We had compromised visibility, unable to increase alert granularity because of the sheer number of hosts and metrics we were monitoring. We had single point of failure, meaning that we were blind when Zabbix went down, and we also stressed the limits, so there were even more downtimes. So let's talk numbers. This translates to about 250,000 backend queries per minute. Again, remember, this is reduced granularity because we're approaching that limit. And in January of 2020, production engineering was alerted at least once every 6 minutes on average. So this is a lot of human cognitive overhead. Many solutions were discussed. So what factors did we consider? The first thing we did right was to not boil the ocean. We decided to build a POC, and what that helped us was to understand the control we wanted to have around our customers' sensitive data, especially with PII and GDPR in mind, and realistically evaluate the cost of buying for our scale at 15,000 hosts and logs of almost 3 terabytes of logs a day. In the end, we found the balance between building and buying by buying an observability platform with the help of a time series database, investing, of course, in InfluxDB so that we have redundancy in our observability architecture. And Nadeem will go into more detail. And lastly, it gave us flexibility to integrate metrics with other data sources and possible ML solutions. So the next thing we did right was build for growth. Was always at the forefront of our minds. This drove new features that were not present in our previous system. Our alerting system always does not have a single point of failure. And Nadeem will go into more detail on how our multi-region alerting and how we thought about disaster recovery. Our pipeline was more robust and interconnected with the help of PubSub. And again, Nadeem will go into more detail. And with the help of InfluxDB Enterprise, we have redundancy in our observability architecture. And we have not been blind since implementation. With 6 node clusters, we support about 5 million cardinality with headroom to grow. And finally, the most unorthodox strategy is that we prioritize sales as an early use case with the hypothesis that if the data is accessible to sales, we will interrupt support and engineering less frequently so that our teams can focus on what they specialize in. Plus, sales will be champions of what we needed to fast track observability. So far, this is paying off because sales is a super effective champion, especially for internal tools. And we've been progressively freeing up our support team to essentially support. So let's talk numbers again. Once I get the slide to forward. There we go. So back to numbers. As a proxy to visibility, we have 20x the metrics that we're writing, plus it's stored in 2 locations. So we have redundancy again. And we're alerting less frequently. So once every 50 minutes now. This is more than 2x improvement on the human cognitive overhead. And we're able to do this because we have better auto remediation, and Nadeem will go into more detail on this, and more granularity with our new platform, allowing less noisy alerts. So to recap takeaways, we made decisions with our core values in mind, specifically built for growth. We eliminated single point of failure where possible, invested in interconnectivity, and invested in redundancy with InfluxDB Enterprise. So thank you so much for your time. Nadeem will go into more detail on our observability architecture and learnings.
Hello, thank you, Tanny, for everything. And hello and welcome. My name is Nadeem Sayed. I am a principal software engineer at WP Engine. When I joined the team over here, we are in the process of building our observability platform. As Tanny mentioned, at that point when we were joining, we were having trouble with our existing platform that we had. So we had to go and build our new architecture, which is more scalable and are able to handle multiple regionally independent, so that if one region of our host goes down, our alerting and everything doesn't go down. In order to do that, we came up with architecture like this. We'll go into detail about each layer, but basically what we did is like we captured all the metrics from our fleet and then put in through various succession and using those metrics for alerting and also storing them and visualizing them. So let's start with our first layer. In order, we have approximately 15,000 hosts spread across Google, Amazon, and various other providers. And besides these VMs, we also have Kubernetes pods which are running in various clouds. In order to gather metrics from these, we are thinking about a robust agent which can help us gather metrics and logs from these. So in order to do that, we are looking at first with Fluentd and a custom-built agent, but we finally settled down for Telegraph because it was much less resource intensive than Fluentd on our host. So we are using Telegraph to gather all the metrics, and the other beauty of Telegraph is that it allows us to have a different custom plugins in order to capture those metrics. Once we have captured those metrics, why didn't we directly write it to Influx directly? The reason why we didn't want to do that, because they were writing small loads and small packets, and if we wrote them to Influx, there could be an overload. So we chose to send those metrics from each region to the aggregation layer. And this aggregation layer and metrics platform, everything is running on the Kubernetes platform. So we can increase the number of aggregator, which can aggregate metrics from per region, and we can also easily sanitize and filter the metrics that we don't want to store or we don't want in our pipeline. And it's all these deployments in our aggregation layer is done using GitOps. So it was easy to change the filter anytime and take effect rather than pushing all those telegraph changes in our fleet. Once we have those metrics, these metrics, we wanted to use them for our alerting use case. So as you can see, each region has its own alerting layer, and the metrics from each region is going to the alerting layer for the same region. In the alerting layer, we had an architecture of using, a capacitor and influx OSS. So why we chose to do this is we are keeping some of the metrics for a shorter duration, which for our use case was most of our alerts use a 6-hour window. So in order to keep that data not in the memory of capacitor, we chose to store those data in Flux, and so that we can use the batch alerting mode for a capacitor. And also we are sending the same data, the copy to capacitor also. So for the stream alerts, we can do that. All of that capacitor task was deployed using the GitOps principle. So we can, someone in our team can check in an alert and it get deployed to all the region at the same time, easier to manage. We handle and the alerts definition and everything is handled using Git. So there are one special use case. So normally capacitor does support us to send alerts to different supported endpoint, but we also wanted, we are also looking to solve one of the major problem in our system was that our support people were getting interrupted and our production engineering team was interrupted with lots of alerts. And most of those alerts could be easily solved using, with no human intervention. So what we did is like we instead of sending those alerts to human, we captured those alerts in capacitor relay and send those signal to the pods and the VMs on the fleet directly. And we have a special agent running over there which can take the signal and do the correction automatically. For example, if there is a need for restarting Nginx because of some problem is happening, then it can send those signals and it can try to auto-resolve those problems. In case if it, after a few tries, if those alerts does not get resolved, we alert a human, so that there are multiple level of redundancy in our alert handling. And all the alerts in this case are regionally independent. So we had tested with the DR, we put down like multiple regions, and our alerts still work for other regions. The next thing that we wanted to do with our data, with the metrics, is that we wanted to ship those metrics not only to Influx, but we also wanted to tap in the pipeline where the metrics are flowing for various use cases. For example, one of the storage we are doing is in Influx, but we are also storing some of the metrics in BigQuery. And we are also planning to tap on using ML pipeline with the data. So that's why we chose to send all the metrics using Google PubSub and then use that to store that data in Influx. Once the data is in PubSub, one of the feature that we are using with this is that if, for example, our storage layer is down due to some outage, we are not losing the metrics. There is a backup, back pressure, and we are storing all the metrics for 1 day in PubSub. So in case of an outage in our storage layer, we can still get those metrics back to us. As far as Influx is concerned, knock on the wood, since we started, we haven't had any problems with Influx Enterprise. We are running a 6-node data cluster with Influx, and it has run smoothly without any problem for us. We are easily able to manage them in order to monitor all of our metrics platform. We are sending our control plane metrics to a different system. We didn't want to monitor those alerts or metrics from the control plane within our system. So we are sending those both to Influx Insight and also to Datadog for our internal use cases. Once we have those metrics, we are also visualizing them using Grafana. We also have a small use case for our internal user for Chronograph, so we are attaching it directly with Chronograph also. But for most of our users are using Grafana because there are existing other data and other plugins which they love, and we wanted to put our dashboards in a place where people are more comfortable using it. We are also using time series, a product called Trickster. This Trickster is a time series cache. So for special caching software which can handle time series data, and using this, our load on our Influx database has gone down dramatically, and we are using Google IP to do the authentication and other related things. And so yeah, so basically, from our architecture, we were able to handle regional outage, and we're able to handle a huge amount of metrics. We are getting, like, for just the metrics alone, we are getting like 25 megabytes per second of the metric. There was another concern we had with that, is that the cost for sending it over PubSub was prohibitive. So we added a feature in Telegraph to compress the data which we are sending to PubSub, and we have also put that up, created a pull request in Telegraph in order to giving back to the community. So there are some challenges in here. So first of all, the challenge that we had is that although we had a regional alerting, our database, that is our Influx, is only able to deploy it in a single region. So if that region goes down, we will lose the dashboarding feature of our platform, but we will still continue to have the regional alerting. There were some also problems with running Capacitor and Influx Oasis in Kubernetes. There were some issues with that, so we had to deal with that. So one of the major problems that we noticed, we are using Influx 1.9, that we are trying to run everything in Kubernetes, but we are having trouble doing that with Influx on running in Kubernetes. So hopefully, once we upgrade or once we have Influx 2, then we'll probably resolve some of those problems, because I'm hearing that it can run in Kubernetes. And then we had some, things moving over from existing monitoring solution to a different monitoring solution was always a bit difficult, but it was challenging and worth our effort. So what's next? So we are looking forward to start using Influx tasks, and probably converting our capacitor task to the Flux task. So we are also gathering all the logs from our fleet and sending it over to our platform, extracting metrics from them and using those extracted metrics from that. And also integrating with various data platforms which we have in our company in order to grow. And then last but not the least, we are hiring, we are a remote first company. We are hiring all across the world. So feel free to hit us, and thanks everyone. Okay, yes. So we did so the first question we have is, did you look at other time series database? And if so, why InfluxDB as opposed to a different one? Yes. So we did, first we wanted to, not build a solution ourselves. We were thinking about using Datadog, but it was so cost prohibitive that we couldn't do that. So then the next option, we tried to do a POC for timescale DB and Influx. Both of them were performing good, but we leaned on Influx because of their Influx support and Influx enterprise features. So that's the reason why we chose to that. Where did you find about Influx? Researching online. How did you convert your Zabbix scripts? In order to convert those Zabbix scripts, those are like manual, painful process. That was the main reason we are looking forward. If our community can build a tool to convert capacitor tasks to Flux tasks, so that so that we don't have to write hundreds and hundreds of capacitor alerts definition to a different one. Don't you find the management of InfluxDB enterprise cluster with 6 nodes too cumbersome? The need to explicitly access and configure every node and all that. So since we are a team, we have a dedicated team for observability. In order to manage this, I think in building the whole architecture, setting up the Influx enterprise was the least amount of effort for us. We were able to do it using Ansible and configure every node. We have like some portion of it is not completely automated, but some portion of it, especially spinning up nodes and bringing it down. Whenever we have to do upgrades, it was usually very simple and painless for us. Is WP Engine using InfluxDB OSS Enterprise Cloud or something else, or combination of those? Yes, so we are using a combination of that. We are using InfluxDB OSS as for our alerting layer for storing the data for a short period of time. We are using Enterprise InfluxDB as a main data store to store. As far as InfluxDB Cloud, we haven't used it yet because our use case was leaning toward an enterprise solution. So do your customers get a dashboard on their own as well? So right now, all the data that we are gathering are mostly for internal use. We are in future, we are planning to see what kind of metrics that we can expose to our customers. I think we are done. If there are any other questions, I'd be happy to take. But other than that, I'd like to say thank you from Tanny and me, and we are excited to be here as a part of Influx community.
Oh, thank you so much. That was really interesting use case and looked like a really big project. So kudos to you guys for being able to do that successfully.